Hello and welcome to a lesson for 10.3 composite functions. So this is something that if you are planning on taking calculus next year, you will use quite a bit when you're doing all of your math through that course. So if you plan on taking calculus, this is an important concept to understand. First, before we move on to the actual composite functions, we need to be looking at if you know how to use function notation. So if I have a function, f of x equals 3x squared plus 4, and I want to find f of 1, a reminder that what this means is that everywhere I have an x, I'm going to replace it with a 1 because the 1 is replacing the x in the function notation. So when I do that, this is going to give me 3 times 1 squared plus 4, which would give me 7. Now, the problem that we have is not usually when you have an actual number to plug in. Where people run into problems is what if I'm not plugging in a number, but I'm plugging in a whole other mess of stuff? So, for example, in B here, we've got a 2a that has replaced this x. What that means is that when I rewrite my function, I'm going to replace the x in the function anywhere it shows up with an entire 2a. So instead of having 3x squared, I'm going to have 3 times 2a all squared plus 4. So the x in the function was replaced by a 2a. That means the 2 and the a are both going to be squared. So if I do that, this gives me 3 times 4a squared, because 2 squared is 4. A squared, we don't know a, it's just going to be a squared plus 4, or 12a squared plus 4. And this is really the entire concept of this section. We're going to use something called a composite function where we make a new function and we're going to plug an entire function into another. So there's a couple different notations that you will see. One is this first one here. We read this as f of g of x. The other one you'll see is this one here. So notice how the f comes first in both of these and the g comes second. So f is the outside function and g is the inside function. This means we're going to plug g into f. So first, if I want to find f of g of 3, the easiest way to do this is to find g of 3 first and then plug that in. So g of 3 in this case would be 3 squared minus 1, because this is my g of x is x squared minus 1, which would give me 8. So what this means is if I want to find f of g of 3, I'm really finding f of 8 because g of 3 equals 8. Now, if I want to plug this in, f of 8 would be 2 times 8 plus 3, or 16 plus 3, or 19. Now, the problem for part B is we're not plugging an actual value in, we're plugging in an entire equation. So what this means is that everywhere there's an x in our f of x, we're going to replace that with the entire function g of x. Okay, so in this case, my f is 2x plus 3. So instead of having 2x plus 3, I have 2 times g of x plus 3, because the x in the function here was replaced with a g of x. Now we have an actual function for g of x. It's x squared minus 1. We're going to replace the g of x with the actual value we have for that. And then we can expand and simplify. So this would give us 2x squared minus 2 plus 3, or 2x squared plus 1. Now I am showing every possible step here. Many of you will not need this many steps. Okay. So f, again, here would be the outside function. G is being plugged into f. I would suggest if this is making sense so far, you pause and try C and D on your own. If you're feeling like this is not quite good yet, then please continue to walk through the next two examples here. For this next one, G is my outside function and F is my inside function. This means I should find F of 3 first and see what that equals. That would be 2 times 3 plus 3 because my function is 2x plus 3, which would give me 9. This means if I want to find G of F of 3, I'm really finding G of 9 because F of 3 equals 9. Now, since G of X is x squared plus 1, that means this is going to be 9 squared, x squared minus 1. This will be 9 squared minus 1, which would give me 80. Again, the next question, G is my outside, F is my inside. This means if my G of X is equal to x squared minus 1, I actually have F of X all squared minus 1 because the X in my G function is being replaced with an F of X. Now, F of X is 2x plus 3. So this means I have 2x plus 3 all squared minus 1. The entire x gets squared. So for this case, the entire f of x gets squared. Our entire f of x is 2x plus 3. Now be careful here when you expand this. This is equal to 2x plus 3 times 2x plus 3. This is not 4x squared plus 9. Then minus 1. This gives us 4x squared plus 12x plus 9 minus 1, or 4x squared plus 12x plus 8. You can factor out a 4 if you want, or you can leave it here. Again, if you think you're fine with this so far, go ahead and pause the video, try the next two on your own, and come back to see the answers. If you're feeling like, nope, I'd like some more direction, feel free to continue. Here, we need to find f of 1 first. F of 1 would be 2 times 1 plus 3, which would give me 5. So f of 1 actually be f of 5 because f of 1 is equal to 5, which would be 2 times 5 plus 3, which would give me 13. This one, I'm going to plug f of x into itself. So because I have 2x plus 3, this is going to become 2 times f of x plus 3. The f of x is replacing x in my equation, which will be 2 times 2x plus 3, or 4x plus 6 plus 3, which is 4x plus 9. So notice that f of g of x and g of f of x are not equal. So this one was f of g of x, and this one was g of f of x. These are not equal. It matters which one is your outside function. The only time these will be equal is if f of x is equal to g of x, if they're the same function, or if f of x and g of x are inverses of each other. Okay. Otherwise, it very much matters what your outside function is. So now we're going to try another question that is not any more difficult, but we're going to be looking at domains of these as well. So first, I'm being asked to find f of g of x and g of f of x. So a reminder, this is just a new notation. F comes first, so that's the outside. G is second, so that's the inside. This means I'm finding root g of x minus 1 because the x is being replaced with a g of x, or root x squared minus 1. And that's the best we can do. We can't simplify that at all. The other question here, g is the outside function. G comes first. That's the outside function. which means we are doing f of x all squared because the x in the g of x is being squared. For us, that means f of x is being squared. So for us, this means that we have root x minus 1 all squared, which would be x minus 1. Now, the next part is new for our notes here so far, which is asking us to find the domains. So domain of f and g, we should know how to do. The domain of f, well, f is root x minus 1. So your domain would be that x has to be bigger than or equal to 1 because the inside of a square root must be positive. For g, g of x is x squared. Well, our domain for a parabola is all real numbers. I can square any number I like. Now, the reason I'm finding these separately is these are going to help me find my domains of my composite functions. So f of g of x is my f with the little circle of g of x, which we just found. And this was root x squared minus 1. Now, when we find domains of a composite function, what you need to consider is the domain of the inside function on its own, and then the domain of your final answer function that you found. The domain of the outside function does not need to be considered on its own. Okay? So we need the domain of the inside and the domain of the final function. The reason is you can't get to the final function if the inside didn't exist in the first place. Okay? So for domains of composite functions, find the domain of the inside function, find the domain of your total composite function, then you're going to use these to create an overall domain. So if both of them are all real numbers, then your overall domain is all real numbers. If one of them is all real numbers, but one of them has restrictions, you need to keep those restrictions. So all of the restrictions in your domains must be satisfied. Okay, so you're going to use these domains to write a final coherent domain. Okay, so for this first one here, our inside function is g of x, and your domain was all real numbers. Our outside function, or our total final composite function is f of g of x, and our f of g of x here is square root x squared minus 1. Now we know that this means x squared minus 1 needs to be bigger than 0, which means x squared needs to be bigger than 1 or equal to 1. In order for x squared to be bigger than 1, this means that x could be bigger than or equal to 1 or smaller than or equal to -1. So these ones tend to trip people up a little bit because what they'll write is they'll say, oh, then x is greater than or equal to plus or minus 1. This is not the case. This is not accurate. And I like to think of this as if I had a graph of x squared minus 1, it would look like this, right? I'd have an intercept at 1 and -1. And where is this bigger than 0? Well, this is bigger than 0 here and here when x is bigger than 1 and smaller than -1. So I find visually that helps a little bit with these domains. So my domain overall for this composite function would be x must be bigger than or equal to 1 or less than or equal to -1. So this is my final domain for f of g of x. Okay. Now I've run out of space because I wrote this giant blurb in red. So I'm going to work my way down just a little bit to the right here for my other composite function, or actually, maybe I can work my way up. I've got a little bit of space here. So I'm actually going to go up over here. I'm just running out of room. Okay. So consider the domain of the inside and the domain of the final function. So I have g of f of x, and this is equal to x minus 1. Now, if I look at just this final function, x minus 1, I would think my domain is all real numbers, but my inside function is f of x. Okay? So my inside function, f of x, my domain is that x had to be bigger than or equal to 1. My final function, g of f of x, is equal to x minus 1. And the domain of something like x minus 1, that's a linear equation. It's a straight line. I can subtract 1 from any number I want. My domain would be all real numbers. But I need to consider both of these when writing my final domain. So my final domain, I need to consider both these things. I have to be able to satisfy both these things. So I'm going to keep the restriction. My final domain is that x is greater than or equal to 1. If x is not greater than or equal to 1 in the first place, I don't get past this step. If I had -5, I can't square root -5 and then square it. I would get stuck. So you have to consider the inside domain and the final outside domain. Put these together to make a coherent domain for your composite function. Now, the last type of question you're going to see is something like these. I'm telling you, this is my composite function, and your job is to figure out what possibly could the outside function be and what possibly could the inside function be. So if I look at the first one, it clearly looks to me like x minus 2 has been plugged into something. So I'm going to say my inside function is probably x minus 2. So according to the question, this is g of x. If that's my inside function, it looks like I probably plugged this in to something squared plus that something plus 1. So this one's fairly obvious. You can see the x minus 2 coming up over and over. The next one's a little bit trickier. There are two possible answers people usually come up with. Okay? The first one that people come up with is, oh, it looks like my inside is x cubed plus 1. That would be my g of x. And it looks like I plugged that into being square rooted. So it looks like I've square rooted the inside, which means that square root x, or my outside, would be my fx. This is one option people come up with. The other option people come up with is that my inside might just be x cubed. If that's the case, my outside function would then have to be the square root of x plus 1. What I would have done is I would have plugged this x cubed inside into this x inside to get x cubed plus 1. So these questions, if these are frustrating you a little bit as you go through, don't worry about them too much. They don't come up very often. And they're usually also sometimes in the book multiple choice questions. And really, there are multiple answers for some of these. So if you're trying the homework question, you have one, and you don't get the same answer, but your answer makes sense, then you're fine. So you can check and see if your answer makes sense by actually plugging your inside into your outside and see if it looks the same. So for B, if I plug those inside functions into the matching outside functions, I get the same H, no matter which one I try. So you're really just looking, and there's not really a rule to follow. You're looking for what makes sense to look like I plugged it into something else.